Welcome back if you've been with us all week. Welcome if you're finding this for the first time. Let me tell you or remind you a little of what we have seen so far this week. We have witnessed mind-opening conversations from the likes of Sebastian Thrun, who spoke on the future of the workforce in advanced manufacturing, Dr. William Roper of the U.S. Air Force, and we listened in on a conversation between Lieutenant General Sean Morris and Brad Keselowski, the founder of Keselowski Advanced Manufacturing. This week we've also had the chance to witness some high-level, high-stakes team competitions that really test the limits of what's possible with advanced manufacturing right now, and we've got much more of that to come. If you're joining us for the first time, welcome to the show. And let me be the first to say you are in for a treat. We're so glad you're here. In the screen next to me, my co-host, our resident astronaut, Mr. Leland Melvin. Leland, why on earth are you grinning so big?
You know, Peter, I'm always smiling, but today is an extra special day, and I thank you for being a great co-host. You know why I'm smiling, because today we are going to leave Earth and focus on space. Advanced manufacturing is a field that offers so many exciting possibilities in propelling our future, and when it comes to space, it's no different. In 2015, one of my actual my friends that flew with me on my last mission, STS-129, was the first astronaut to print 3D printed parts in a made-in-space 3D printer. 104 layers. It made a ratchet wrench, and there have been many things printed since then. But if we're going to go inhabit the moon or Mars one day, and we don't have the time to get spare parts shipped up there, we're going to have to make things in situ and figure out how to do that. So that's why I'm so happy, and I just can't wait to talk more about this today.
So you raise an excellent point. I've seen that ratchet. The astronauts are teaching us a lot about manufacturing, just because your manufacturing challenges are so extreme. You know, how to do spare parts effectively. We've heard that. As part of this program this week. The Air Force faces that challenge. Boy, spare parts in space, that is a whole other level. Here's something else we want to remind you of if you're joining us for the first time, or if you missed sessions from the past 2 days, it's all still available. All that content is out there. Make sure you check out our on-demand video section to catch up on all of the content we've put together in previous days this week.
Yeah, that's really great content, Peter. And before we kick the day off, I would like to remind you all of the deadline for the printer shootout submissions. Be sure to get those in by 10:59 a.m. Eastern Time. Again, that's 10:59 a.m. Eastern. And make sure to use the hashtag AMO2020.
Yeah, it's your participation in these live real-time contests that is making this event so dynamic, bringing it to a different level. And it's just a reminder of what advanced manufacturing is and how it plays out. It's a technology, but it's a community too. So let's not delay any further. Let's get started with the program today with our first sequence of speakers. So first up is General John Raymond, Chief of Space Operations.
And after General Raymond, former astronaut Dr. Mae Jemison, joining us live to deliver a keynote speech on the 100-year Starship program. I've been lucky enough to know her, and I can't wait for you all to meet her too.
But first, once again, we have Lieutenant General Sean Q. Morris to introduce our first speaker.
Ladies and gentlemen, what a perfect backdrop from which to introduce our next guest. I am elated to introduce and welcome General Raymond, our first Chief of Space Operations in the United States Space Force, to the AMO stage. General Raymond gets to do something few get to experience: stand up a new branch of the armed forces, the United States Space Force. General Raymond has a proven track record of leadership across the Office of the Secretary of Defense, Air Force Space Command, United States Strategic Command, and as the Director of Space Forces in both Operation Enduring Freedom and Iraqi Freedom. I'm ecstatic to have General Raymond join us today to share his insight in how emerging technology plays a vital role in the United States Space Force mission.
Good morning and greetings from the Pentagon. Thank you, Lieutenant Morris, the Air Force Life Cycle Management Center Commander and the Rapid Sustainment Office Program Executive Officer, for your leadership in establishing this inaugural event and for bringing together academia, industry, and government to discuss the importance of advanced manufacturing to the United States Space Force. Today, I'd like to share with you the imperative we are facing in space, the Space Force's priority lines of effort to address it, and how advanced manufacturing will contribute to competing in the domain. America is a spacefaring nation and has long led military, civil, and commercial space sectors. Today, we are entering a defining period for this country in space. Our nation is leading an expansive spirit of space exploration and experimentation, and we are strongest when space is secure, stable, and accessible to enterprising Americans for scientific, economic, and security efforts. This year, NASA resumed launching American astronauts from the United States soil, with plans to return to the moon by 2024. Our commercial space sector has lowered the cost of launch and demonstrated the potential of proliferated constellations. As a result of these and other factors, we are seeing significant growth across the space industrial base. Today, every instrument of American national power is underwritten by a stable, secure, and accessible space domain. But the rise of peer competitors is dramatically changing the global security environment, and space is central to those changes. Our competitors aim to build space capabilities to give them the same advantage that the United States has enjoyed for so long. In a conflict, they also intend to degrade our capabilities to reduce the lethality and effectiveness of joint and coalition forces around the globe. Access to space and freedom of action within the domain can no longer be assumed. They must be underpinned by strength. These facts have compelled a change in strategy, law, and policy. The National Defense Strategy calls the Department of Defense to compete, deter, and win. The 2019 National Defense Authorization Act is the United States Space Force's birth certificate. The Space Force is the implementation of national strategy. We were born to compete for freedom of action in space, to ensure joint force lethality, and to provide independent options to decision makers. Space professionals owe the nation space power. Let me be very clear. We do not want to get into a conflict that begins or extends into space. We want to win in competition. We want to deter conflict from ever happening. However, a credible deterrence requires a capability to deny adversaries their desired outcome or to impose costs upon them. A war that begins or extends into space will be fought over great distances at tremendous speeds, posing significant challenges. Just look at the United States Space Command Commander's area of operations. The United States Space Commander's AOR extends from 100 kilometers above the Earth's surface globally and higher. Our on-orbit capabilities move at speeds greater than 17,500 miles per hour. Direct ascent anti-satellite missiles can reach low Earth orbit in a matter of minutes. Electronic attack and directed energy weapons move at the speed of light. So as the threat evolves, so must the way we organize, train, and equip space forces. As an independent service, we are responsible for several things. First, we must professionally develop our people. We must develop our doctrine. We must develop our budget. We must design our force, and then we must present that force to combatant commands. We're evolving across all of our responsibilities to address the increasingly contested and competitive character of the domain. My guidance to space professionals at all levels is to be bold, to be innovative, to leverage the outstanding talent that we have, and to be lean, agile, and fast. Since establishment, we have slashed bureaucracy, delegated authority, and enhanced accountability. Big organizations are slow, and we are moving at speed to outpace the threats that we face. We just completed the largest reorganization in the history of national security space. We removed 2 echelons of command, shortening the distance between decision makers and you, the experts. But internal service actions are only part of the solution. We have a huge opportunity to be a disruptive innovator, an incubator for change across the entire Department of Defense. And that opportunity extends to you, the experts on the net across government, academia, industry, and small business. These Olympics provide the opportunity to expand our cooperation on advanced manufacturing, to enhance the nation's prosperity and security in space. I believe there are endless applications for these technologies in the domain across RDT&E, operations, acquisition, sustainment, and logistics. Today, our space capabilities are by far the best in the world, but they were built for an uncontested domain, and we must build for the future. We have to protect what we have on orbit today. We then have to bridge to a more defendable architecture, a resilient warfighting architecture, able to meet the threat while reducing the first mover advantage. Third, we need to have the ability to give a punch and provide independent options from space. And finally, DoD must identify what other missions should be conducted from space. And we must do this in a manner that is fast and responsive within a dynamic threat environment without breaking the bank. Advanced manufacturing is rapidly transforming the way space capabilities are designed and delivered. Spacecraft fuel tanks, antennas, structures, and engines are already being produced via techniques with materials uniquely tailored for space. These technologies allow us to move rapidly from capability design to prototyping and into production, yielding consistent results while avoiding waste and reducing costs and extending our lifespan of our systems. Further, advanced manufacturing increases the feasibility of in-space manufacturing, servicing assembly and sustainment missions. Moving forward, the Space Force needs to scaled advanced manufacturing techniques across our enterprise to improve readiness, agility, resilience, responsiveness, and performance while lowering costs, risks, and integration timelines. Building the Space Force is the first digital service, and implementing digital engineering reduces barriers to entry for small businesses, accelerates development, and reduces R&D investments. ESATs, or digitally engineered spacecraft, allow for parallel and rapid development, testing, and certification in digital environments and expands the opportunity space for adaptive manufacturing across a capability's entire life cycle. I'm certain these capabilities will transform space operations and sustainment. Thank you all for working to help us transform the national security space enterprise and to address a growing and significant threat with speed. Our measure of readiness today is the ability to prevail in a conflict that begins or extends into space. We are committed to winning in competition, and you and your ideas are a key element to ensuring we can. Together, we make a world-class team. Semper Supra.